This is a ballistics pendulum, and a ballistics pendulum is used to figure out the initial velocity of a bullet or something shot into another block. And basically what we do is we use the law of conservation of momentum together with the law of conservation of energy to figure out how fast this bullet had to be going here in order to get the pendulum to swing up to a height h there. And we do this using a combination of the laws of conservation of momentum and the laws of conservation of energy. So this is an inelastic collision, which tells me kinetic energy isn't conserved, but momentum is always conserved as long as we have a closed and isolated system. Well, before this thing hits, and when it hits, we do have a closed and isolated system, but when the pendulum starts swinging up, then gravity starts to act, and that makes our system not isolated. So we can't use the conservation of momentum over there, but we can use it in the collision over here. So initially, or before, what we have is we have a little bullet, which is little m, and it's moving with velocity v0. So this is our momentum before the collision, which means after the collision that momentum is still the same, and so this is equal to big M plus little m, because these two things stick together in the pendulum and they're going to move with some speed v. Alright, so that's the law of conservation of momentum. Now over here I'm going to do this with energy, and this takes place after the collision. So I have no more collision at all. Instead I have kinetic energy, because when the bullet hits the block it's going to start pushing it, making it move. So the kinetic energy, I guess this is before the swing. So this is the swing over on this side, and this is the collision over here. So before the swing, the kinetic energy is equal to big M, the mass of the block, plus little m, the mass of the bullet, times however fast they're going, squared, times 1/2. That's kinetic energy. But after the swing, that energy is converted into potential. So this is equal to big M plus little m times gh. Okay? So I have two laws going on. I have the law of conservation of momentum for the collision and the law of conservation of energy for the swing. And so now all we have to do is solve all this mess for v0. Well, I see v over here and I see v0 and v over here. So I'm going to go ahead and I'm going to solve this equation for v. So I see that v is actually equal to little m times initial velocity divided by big M, the mass of the block, plus little m. Alright, so now I can make this substitution into my energy side. So I'm going to go ahead and I'm going to do that. So I have 1/2, let's break this out, 1/2 mass, which is big M plus little m, times velocity squared. Now you got to be careful with this. This is m v0 over big M plus little m, and this whole thing gets squared. Now this is equal to, according to my conservation of energy, big M plus little m times gh. Alright, so all I want to do now is solve this for the initial velocity and I'll be done. I want to know how fast that bullet was initially going. So what I have is this 1/2 and this m, and okay, so let's deal with this square. So 1/2 big M plus little m. Okay, now this square acts on everything in there. So times m squared v0 squared over big M plus little m squared equals m plus m gh. Let's do some algebra and get rid of some stuff that we don't need to see anymore. Okay? This big M plus little m cancels that square, so I'm done with that. Okay? And then I have m squared v0 squared over 2, right, this is the half, times m plus little m equals big M plus little m times gh. Now I'm going to go ahead and I'm going to multiply the denominator over to the side. So I have m squared v0 squared equals twice big M plus little m squared gh. Divide both sides by little m squared, and I get v0 squared equals, I'm going to do some rewriting now, big M plus little m over m squared times 2 gh. Now all I have to do is square root both sides, and what I see is that v, the initial velocity v0, is equal to big M plus little m divided by little m, that square root cancels the square, times the square root of 2gh. That's what I wanted to show. That shows me right there conservation of momentum and conservation of energy in order to solve for the bullet.